Okay, so now we have y equals x, which is a nice straight line. Let me draw that first. Y equals x. Y equals 0 is the x-axis. Okay. X equals 2. So let's say that's 1. This is 2. So we're talking about the x-axis, and now this 4, 3, 4. So now we're talking about that. So we're talking about this area. And we're going to rotate this about x equals 1, so which is this. Okay, so then that means we're going to get a shape. Okay, so this is 0, -1, -2. It's going to go up to 4, 2, 3, 4. Should be symmetric on this other side. Okay, so we're going to rotate like this. Okay, so I hope you can see that shape. Okay. Okay, so the circles, the cylinders are they're horizontal right now. So the x value, right? The x value is the radius. So the way we're going to do this is the following. We're going to get that circle, okay, that cylinder, at a particular y value, okay, at a particular y value, that's the center, and we're going to subtract of this cylinder. Okay, I'm talking about really thin cylinders here. Okay, so then I need to do, first of all, what is this radius, okay, as a function of y. So radius, let's call it radius 1 as a function of y. And of course, second of all, I need what is that radius as a function of y. Alright, so let me do radius 1 as a function of y first. Okay, normally it's just x, but here, because we're rotating about x equals 1, it's not as simple as that. Okay. Okay, now we have to go back to the function that's given, which is, so there's a lot going on here, but you gotta focus your attention on this line now. Okay, so this line. Okay, so what is this radius respect to this, the x value on this line, right? So it's not x, right? It's going to be a fixed value of, from here to here is the value of 4. So it's 4 minus that x value, okay, from there to there. So if you do, so it's always 4, but you just subtract more as you go more further to the right. Okay, do you see that? So it's 4 minus that x value, but x is equal to y, and we want it all in terms of y. So it's the radius, the first radius r1 is going to be 4 minus y. Okay, for r2, right? Okay, for similarly, right? This is the fixed distance from there to the y-axis. It's 2. So it's 2 minus the x value again. So 2 minus the x value, which is same as 2 minus y. Okay. So hopefully you can see that. Now we're almost done. We just have to integrate along the y now. We're integrating from 0, right, all the way up to here, right? And that point right there is going to be 4, 4. So you can see that we're going to be integrating from 0 to 4, and it's going to be pi radius 1 squared minus pi radius 2 squared. Okay. All right. So pi 0 4 radius 1 squared dy, pi 0 to 4 r2 squared dy. And replace r1 with this. So it's 4 minus y squared dy, right? 2 minus y squared dy. Okay. So pi, let's get the antiderivative now. Actually, no, we have to expand that. So it's going to be 16 minus 8y plus y squared. Okay, and zoom in a bit. 0 to 4. This is going to be 4 minus 4y plus y squared. Okay, so pi times by 16y minus, it's going to be y squared times by half, so it's going to be 4y. It's going to be y cubed times by 1 over 3, the reciprocal. So I did that relatively quickly because I'm assuming at this point you guys know how to do this basic antiderivative quickly. Okay, here too, it's 4y minus, it's going to be 2y squared plus a third of y cubed. Okay, 0 to 4. All right, we're almost done. Okay, so pi, let's plug in 4, it's 64 minus 64, if you put 4 squared in there, 4 in there to get 4 squared, plus, okay, this is 64 over 3. Plug in 0, everything will disappear, so that's fine. Here, let's plug in also 4. So it's 16 minus 16 times 2, so it's 32 plus 64 over 3. Okay, so that's gone. So from the first bracket, we get 64 over 3 pi. From the second bracket, we have a minus 16. Okay, minus 16 plus 64 over 3. That's a minus 48 plus 64 over 3. Okay, that's 16 over 3, right? 16 over 3. So you get 16 over 3 pi. So we have 64 minus 16 pi over 3. So you get 48 over 3 pi. Okay, I think which is reducible. This is 16, right? 16 pi exactly.